Hello, this video is on section 6.4, which is titled Properties of Rectangles, Rhombuses, and Squares. And there are two learning targets for this one. The first one is to define and classify special types of parallelograms, and the second is to use properties of diagonals, of rhombuses, and rectangles. So let's go ahead and get started. All three of these shapes, rectangles, rhombuses, and squares, they are all parallelograms. So they all have the exact same characteristics of parallelograms, and that means that the opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary, and also the diagonals bisect each other. But a little bit more specifically, rhombuses is a parallelogram that has all four sides congruent. So instead of just the opposites being congruent, now all four of them are congruent to each other. You still have the same opposite angles are congruent, and consecutive angles are supplementary. Then for a rectangle, it is a parallelogram where you have four right angles. So you still have opposite sides are congruent, and these two opposite angles are congruent as well. It satisfies every single criteria of a parallelogram. And then a square has four congruent sides and four right angles. So think about it as a combination of a rhombus and a square. You have four congruent sides from the rhombus and then the four right angles from a rectangle. And that gives you a square. So that's kind of going through the first learning target, classifying the special types of parallelograms, where you're more specifically with the rhombus, rectangle, and square. They are all parallelograms, and they just have a few extra criteria as far as the congruent sides and right angles. And then the other target talks about using properties of diagonals of rhombuses and rectangles. So for both rhombuses and rectangles, let's assume that we're just talking about a rhombus first that has four congruent sides. When you're drawing diagonals of a rhombus, the diagonals of a rhombus are congruent to each other. Or no, the diagonals bisect each other. Each other. Okay, so that's still just like with a parallelogram, that the diagonals cut each other in half. Just like, because since a rhombus is a parallelogram, that's following the exact same criteria. Now with a rectangle, it's a little bit different. Four right angles, with a rectangle, the diagonals, these are the ones that are congruent to each other. So if this is A, B, C, D, the diagonal AD is congruent to the diagonal BC. Those two are the exact same length. They also bisect each other just like a parallelogram does, but a little bit extra to make it a more special parallelogram. That is saying that the two diagonals are congruent to each other. One more thing about the rhombuses that I forgot to include is that the diagonals of a rhombus bisect the opposite angles. So as you are looking at what the diagonal is doing to each of the angles, when you create a diagonal from one corner to the other, you're splitting the entire angle up so that each side is congruent to each other. Let's see if I can draw this. Okay, so this is basically saying that this angle is congruent to that one when you draw a diagonal, and this angle is congruent to that one. The diagonals are also perpendicular bisectors. Now what that means is that when you create the two lines of the diagonals, they form right angles at their intersection. I know it's a lot of drawings all in once, but just know that they form right angles at the intersection. That's the most important thing about the diagonals with the rhombus, is that they have right angles in the middle. All the other ones are kind of exactly like a parallelogram, but when you want to be more specific talking about a rhombus, just know that when you create diagonals in a rhombus, they form right angles to the intersection. It doesn't work with a rectangle. These are not right angles. It just is saying that this line is congruent to that one. Okay, so we're going to go over a few examples in class talking about more specifically all of these that entail inside of a parallelogram. And yeah, thank you.